Alright, hi, I'm making a video on an introduction to circuits. So the first part of this video is a question for you actually. So for those of you who attended lecture, for those of you who attended lecture might just know this already. Um, Here's a diagram of a very simple circuit. Here's a battery. We have the positive end over here and the negative end over here. And it's attached to a light bulb with two wires, one going here and one going on the bottom of the light bulb. So my question to you is, why is this the configuration necessary for the light bulb to light? So I encourage you to pause this video and try to answer that on your own. Okay, so now that you've tried that on your own, um, uh, let's let's go through an explanation of why this circuit works. So to understand why this circuit works, we actually have to take a look at the battery first. So um, oftentimes batteries are labeled with a positive and negative terminal. What does that mean? Well, actually, what's going on in the battery is that there are chemical reactions happening that are separating charges in the battery into positive, or actually, what this means is a lack of electrons. Not necessarily positive charges moving here, but more that electrons are actually being shuttled to the bottom end of the battery. And what this is doing is it's creating two plates with positive and negative charges. And if you recall from electrostatics, whenever you have two plates of opposite charge, you create an electric field between the two plates. And what this electric field does essentially is create a voltage drop, a potential difference between the two plates. And what this means is that any charge at this plate, any positive charge at this plate, has a higher potential energy than any charge at this plate. So because objects in nature always want to reduce their potential energy, if there is a path for a charge to travel from the positive to negative plate, it will do so. So the whole idea here is that a battery creates this potential difference, which is why it's labeled as, which is why it's called a voltage source, which is why oftentimes you'll see a voltage rating on here. Like 1.5 volts means that the difference between the positive and negative plates of this battery is a difference of 1.5 volts. So going back to this discussion, what this separation of positive and negative charges does is it creates an electric field, which means that any charge with a possible path from the positive negative plate will want to take that path, any positive charge. So equivalently, any negative charge on this side will want to take any possible path towards the positive charge. And so what you see here is that what provides such a path is in fact the wires. So the wires have to find so the wires are what provide a path for actually electrons to move towards the positive end of the battery. So their eventual final destination is here. Now, how do the electrons get here? They have to pass through the wires, and really they continue passing through several conductors. And here's where we get to how the light bulb lights. So the light bulb, if you take a closer look at it from the inside, the light bulb actually looks like this. So what I've drawn here is the actual representation of the light bulb. What actually happens is that so when we look at a light bulb, there's a small scrawny wire called the filament. And if you notice, a filament has two sides, right? One, two. And one of these sides is connected to the bottom part of the bulb, which you often see as like, I don't know, it's like a little tiny metal nib, right? And the other side of the filament is connected to the metal body surrounding the bulb. So coming back to our circuit over here, the electron's path is really, it goes through the tiny nib on the bottom, it comes up through the filament, down through the filament, uh, around to the casing, and this wire is touching the casing. So the electron is able to take this path over to the positive end. So that's how the electron moves, right? And the reason the light bulb lights actually is because of the fact that it's moving through this filament. Now, this filament has a special property that whenever something small moves through it as fast as electrons actually do, they move very quickly actually through a circuit. They heat up very quickly. So like the friction, essentially, it's not really friction, but you can think of it as friction between the electron and the material in the filament. The friction creates a lot of heat, and as the filament heats up, it gives off light. Like if you've noticed something being turning red hot, that's really the same principle that goes on in an incandescent light bulb. That the electrons are moving through, they're creating friction, they're creating heat, and that heat is what's creating light. So that's how the light bulb lights. We're using the energy of we're using the motion of the electron in order to cause the light bulb to light. So yeah, so that's the reason why we need such a configuration where we have a complete circuit from from the positive end of the battery to the negative end of the battery. So some finer points of this. So the electron is actually moving from the negative to positive end, but often in physics we talk about current, or the flow of electrons, because this is not just one electron. Many electrons are going to flow because there's many electrons over here and a huge absence of electrons over here. So electrons are going to flow this way, and this is called the actual current. But in physics, we tend to think about, and this is due to historical reasons, we tend to think about this current called the conventional current. Conventional current, which moves from positive to the negative end. And we can basically just think of this as the opposite of the motion of the electrons. Or you can think of it as like sort of the motion of positive electrons, because what you're having here is that you're having negative, like you're having negative particles moving this way. So you can think of it as positive particles moving this way. It's I guess it's kind of confusing, but the idea is that conventional current is how physicists tend to think of current because of historical reasons. They know that like there is an understanding that the electrons move from negative to positive. That's the astral current, but we tend to use a conventional current. Also, some other terms. So this is the difference in potential energy between the positive and negative plates is called the potential difference, or the voltage. And finally, something like a light bulb is called a load or a resistance. So it can be either called a load, which is sort of like a burden on the circuit, or a resistance on the circuit. And what we mean by resistance is that it essentially, the higher so resistance is really the quantifiable version of load. So we say that whenever the resistance is higher, say the light bulb needs, I mean, it's kind of complicated to explain right now. I think other lessons will do it better. But the resistance is essentially a measure of how much, sorry, how much, essentially how much, I don't want to use the word load, but I guess I have to. How much load the circuit, this piece puts on the circuit, so that it tries to restrict the flow of the electrons. So that's what the resistance is. So that's another term you'll see come up often in circuits. So this is the voltage, this is the resistance, and conventional current. Okay, so that's a very basic intro to circuits. I hope you enjoyed that, and see you later.